Hello everybody and welcome to our webinar. Today we are going to talk about Oxygen 5.6, the user experience update. Before we start with our webinar, I would like to talk about some organizational things to allow other people to log in, because I see that people are still trying to log in. On your right side of your webinar tool, you can see a chat. This chat is used to ask us questions. Those questions are anonymous and only me and my colleague can see them, nobody else. We will answer those questions at the end of the webinar. There are also some handouts available for you for download during this webinar directly below the chat. So that's about organizational stuff. Let's start directly. Today, I'm joined by my colleague, Verena Niederkofler, know-how expert and application engineer at DEWETRON. Hello, Verena.
Hi, Ivica.
Perfect. Thanks to be on the show today. And my name is Ivica Paresic. I'm business developer and sales for DEWETRON here in Austria. And we are going to start with my very first question for you, Verena. An important and very amazing feature is released with this Oxygen. And yes, TEDs are supported now. And can you tell us for what TED is used for and what trial modules are or do support TEDs now?
Of course, you should be able to see my screen, right?
Yes,
Just
I'm
to
able
be sure. Okay, perfect.
Yeah.
TED support. So TEDs stands for Transducer Electronic Data Sheet, and is a chip which is implemented in the sensor, which reads out all the settings. And we are able to support that now. So we have 2 or 3 different modules which support it. So once we have the Trion 2402 DACC, where TEDs is supported, but only in the IEP mode. So as you can see up here, we have this TEDs button, which is for this board.
Verena, can you, I just see your screen, it's like frozen. Can you try to reshare it? It's still the Oxygen 5. Yeah, it looks like it's frozen.
Okay, hold on.
Yeah, it looks better now.
Does it work now? Okay. So you can see the detailed setup?
Yes, but it still looks like it's frozen. Because the signal on the below is not running.
Well, that's interesting. Well, I guess that's a problem with the GoTo meeting now.
Yeah.
We'll try again.
Oh yeah, it's running now. Oh yeah,
now?
it's perfect. Yeah,
Perfect.
It's running. I see the signal.
Okay.
Perfect.
Okay, so again, so IEP, no, TEDs, sorry. TEDs is supported by the 2202 multi and the 18X multi board, and the 24, sorry, now I'm confused, 2402 DACC board. For this board, it is only supported in the IEPE mode. So as we can see up here, there's the TED sensor. For this board, it is per default disabled, so we have actually to click on the button. I have an accelerometer here connected to this channel. And if I click on this button, it turns green. And as you can see, all the settings are applied automatically. So you have the range, the unit. Here we have this TEDs tab, where we can see which type of scaling is used and which sensitivity. Additionally, we can see this description or the type of the TEDs up here. And if we click on it, we can see all the information written from the TEDs, where we can see it. In order to disable it, we can again click on the button and all the settings are reset to default. In addition to that, for the multi-boards, TEDs is always scanned, so you don't have to click on the button up here to scan TEDs. Since this, there's a sensor connected to the system, but since the button is gray here, no TEDs is detected, so there's a sensor without TEDs. For the next one, I have a tuning fork connected and I have the TEDS disabled. If I enable it, I can see that there's an unsupported TEDS on the sensor. So the settings cannot be applied and I have to disable the TEDS. So that's just as an information for the different states of the TEDS. So if it's green, the TEDS was detected correctly, all the settings are applied. If it's red, the TEDS is not supported. So it can be gray without the line. There's no TEDS detected. And to disable it, just click on the TEDS button and no TEDS will be scanned anymore. Okay, so that's it for the TEDS, as you can see. So it's very easy to use, just connect the sensor and the settings will be applied.
So a very, very important feature, and so easy to use, and that's why it is so very important and asked very often by our customers to be able to have TEDS. There is not a lot to show because thanks God it's done everything automatically, and that's the reason why it is implemented now within our software OXYGEN. So thank you about this. Let's go to the next feature. Our CPAD hardware got some love too. For those who don't know what a CPAD is, these are small additional hardware bricks which are being used for slow or static measurements. They communicate over CAN, and until now it was necessary to use DBC files to implement them. But now this changed.
Now this changed, right? So now it's really easy to use, even easier than before. Now no DBC file is needed anymore to decode messages. So I have a CPAD here, which you can hopefully see, with a to measure temperature. And I have it connected to my CAN module. So there's actually two ways to get the data to add the Decoder Plugin, which is called like that. So either I can click on my CAN channel, click on plus, and here I can choose my CPAD decoder, or I simply open the channel settings of the CAN board and I can click on the Add Decoder button here. I have the normal CAN configuration settings down up here. And whenever I set the baud rate, I can simply click on Add Decoder. And as I can see here, I get a new section in the channel settings, in the channel list. Again, I can change the input channel, so I can select another CAN channel if needed, and I can select the baud rate of the CPAD here. And that's it actually. So it's just one click without the DBC file. And here we can see the temperature measurement, which is sensor not working right now. I think we have proven that we are live enough today.
Yes.
Okay. Well, that is to show it now before it was working. Anyway, just to show you how it works, the CPAD decoder, that's actually it. So you get those messages here. Let's try another channel. Oops. Yeah, okay, well, the sensor doesn't want to do anything right now.
Okay.
Well, okay.
I mean, it's a thermocouple, it could be broken, so it doesn't matter. But we get the message.
We get the message.
Yeah.
Well, anyway, but you could see that it's really simple to add the decoder, which is the core feature here. So yeah, sorry about the sensor.
Yeah, no problem. No problem. So that's about adding CPAD, so no DBC files anymore. As you showed, it's just one click and the CPAD is in the channels menu and just easy and very easy to implement now. And a very important new software feature is that we added a second possibility to decode CAN messages. Can you tell us something about that new feature?
Yeah, so that actually also just to show you, so you can load DBC files or also our ARXML files here. So that's another possibility to decode CAN or CANFD messages. So we also
Perfect.
support that with that version now.
And I guess you're not allowed to show any ARXML files because of some customers who we had to sign something and we're not allowed to show ARXML files.
Yeah, I don't have one here which I can use.
Okay.
But the
Okay.
important thing again is to have this feature implemented.
Yeah, perfect. So that's even a feature that was requested by one of my customers who are testing batteries, for example, in automotive, which was very necessary to have that ARXML file implemented. Yeah, the next feature for TriNet customers, which use multiple TriNets, this feature could be very interesting. So what happened with TriNet, and yeah, tell us.
Yes, so we have a new section, no, the Oxygen Net section is not new, but we have a new section in the settings here. So these are the TriNet settings. So we have the three different possibilities of claiming of the TriNets. This was implemented because some customers had or used different or many TriNets within the same network. But they should not be used all by one computer. And until now, all the TriNets got claimed by the first Oxygen which was running. And since if you want to use different TriNets within the same network on different computers, it wasn't working. Now this is solved with this. So you have different settings here. You can disable the auto claims. So you have to actually claim every TriNet device manually. You have the settings auto claim USB. So only the TriNet devices connected by USB are claimed automatically. But if you have connected them via LAN, they're not claimed, but you have to claim them manually. Or you also have the settings as it was before, that all TriNet devices will be claimed automatically. So these are the three settings, and per default, it is set to auto-claim USB.
So this is very important for those who use multiple TriNets, as we said, in a huge network, and different people are doing different measurements, and that was not possible until now. And now it's possible to claim the TriNet that you would like to use, and another colleague can claim another TriNet in the same network. So this is really, really impressive and nice. So another feature, in some cases, it is necessary to check the sensors prior to the measurement if they are supplied the way they should be and if everything is correct. We implemented a feature to do so. Can you tell us something about the excitation monitor mode?
Yes, so we have actually two new modes implemented. So this is the excitation current monitor and the excitation voltage monitor. It can be used, as you just said, for two different things. To firstly check if the sensors are correctly connected to the data acquisition system, and secondly, to see if the sensor can be supplied sufficiently. So if the maximum power supply is exceeded. So let's go over this. I do have a sensor here to try it and to show you. So for voltage excited sensors, we do use the excitation current monitor because we measure the current consumption over the sensor to see if it is correctly connected. These two modes are especially important or useful if you have very long sensor wires, if you have like long distances where you cannot always check if the sensors are connected correctly. So we click on the excitation current monitor, and here we get the settings of the excitation. Since it's a voltage excited sensor, we set it to voltage, and we set our voltage excitation voltage. We can see it already down here, but let's go back to the screen so you can see it better. Okay, so here we measure the current consumption of the sensor, and we can see that the sensor is connected correctly. Otherwise, if it was not connected correctly, I just unplug it. So we almost measure no current. We're in a microampere range. So if I connect it again, the current is back, and we can see the sensor is connected correctly, and we can we can start measuring. On the other hand, so it's just the same for current excited sensors. We measure the voltage drop over the sensor caused by the sensor. So we do take the excitation voltage monitor, we set it to current, and set the excitation current. Down here again, we can already see it, but let's go back to the screen, and we can measure the voltage drop. If it is not connected correctly, we measure the compliance voltage. So we know the sensor is not connected correctly. There's something on the wire, I don't know, some problem, and we can go check it. And if we connect it correctly again, we can measure the voltage drop. Okay, so that is the mode how to see if the sensors are connected correctly. And on the other hand, we can also measure if the maximum power supply is exceeded. That works the same, but we use the same excitation voltage monitor. So for voltage excited sensors, we use the excitation voltage monitor and set it to voltage, and can set it to 5 volts, for example. And we can see down here, we can measure it back, so the sensor can be supplied. If I set it higher and we cannot measure it back correctly, so it's only almost 6 volts, the maximum power supply is exceeded, and we cannot sufficiently supply the sensor. Same with the current excitation. So we set it to current, and we can measure back the 20 milliampere of the excitation current, what we set here. So that's just the same procedure where we can see if the maximum power supply is exceeded. So for a good workflow, I would recommend to have a setup where you set all the sensors, set it up with the excitation current or voltage monitor mode for each sensor, have an own setup for this, and here on the measurement screen you can have digital meter or indicators where you can see, indicators where you can see, just to show you, for example, an indicator. You can apply the sensor, and then you can apply an upper and lower limits with colors where you can directly see if the sensors are connected correctly. And if everything is green, then you can load your real setup and then start measuring. So you can be sure everything is connected correctly.
So very nice. Again, a bunch of indicators on just one page. And if all indicators are green, you are good to go. Your sensors are supplied. And if there is one sensor red, you need to recheck if that sensor is not connected the way it should. Very, very important for having, if you have a bunch of sensors connected to your system, and you need to know if they are all working or if they are supplied the way it should, the way they should be. Very nice, very nice. The next feature, because we are having a lot of features, even also for this release, header data. So in this important, that's a very important new addition. Can you tell us what is new with our header information?
Sure. Okay, so as you can already see here, I opened the system settings and went to our header data. You can see there's 2 types of header data now. So we once have the text header and the formula constant. To add a header, you simply click on the plus, you select text or formula constant, and I define a value, for example, x, which is 5. And then we add another formula constant, because for the formula constants, we can use them in our formulas directly then, which is very nice. Okay, so we have simply added our headers now here. And now I return to my channel list and I add a formula. And in the section on the 6th page, I can see now all my defined header or all my defined formula constants, which I can simply use in my formulas. So for example, I say x plus y, and then I need a time-based where I just simply use a channel times 0. And I can see now this is 12. We don't need a unit, so we delete the unit here. And let's show you on the measurement screen. So we have our results here. And if I go to the system settings in the small menu, I can also see my header data here, which is simply drag and drop on my measurement screen. And here you can see the results. Let's make it white so we can see it better. Okay, perfect. And as these are formula constants, they are updated in the formula whenever I change them. So if I change my x here to 1, you can see the formula constant changes and also the formula itself changes here. Another nice feature is that this is possible with also via Skippy, so the SCPI. Therefore, I wanted to show you also how that works. I opened my Skippy app, how to remotely connect to OXYGEN. So I made a connection. Now we are connected. And there's two different or couple different comments. And we can also, so we can add formula constants via Skippy, or we can set it to different values. So to set a different value, we use the command set numeric constant, constant. And then we want to change the y, for example, to, tell me a number.
5.
5, okay. Click OK, and as you could see, y is now set to 5. In order to add a new formula constant, we change the set to add, define a new variable, let's say Ivica, and you want to be a 10.
Of course.
Of course. And now we can see the header data. It is updated now with the new formula constant and with the value which is ready to use now. This is very nice and a very nice feature, for example, on test tracks where you want to compare a velocity to a reference velocity, for example. That's why I made like a reference velocity formula constant here, or also on a test bench where you measure different motors, different machines, and you have different parameters for in one set, like you use one setup for different machines, for different motors, and they have different parameters, and you can simply use the same setup and change your parameters via Skippy or with the formula constant directly in OXYGEN.
Perfect. Thank you for that. So I had an application where the customer needed the beginning temperature of his motor as a constant for the whole measurement, and that would be something like that. Before starting the measurement, you enter the temperature and you start the measurement, and you could do all the calculations that have been necessary for further further investigations. Perfect. So yes, that's about headers. And another feature that was changed or got some changes as well is our trigger feature got some changes. What are these changes?
So we have two new Oh, not the export, sorry, the trigger. So we have a new setting here down below in the advanced settings. So we have the stop measurement after, which, as the name already says, stops the measurement after the defined period of time. This works in the event-based and in the continuous mode. So I simply click on a checkbox, define 5 seconds. That's it. And then I go back here, click on record. And after 5 seconds, we can see then that the measurement has been stopped automatically. Yeah, so that's very simple but nice feature. So you can actually have like data files with the exact same size. You can create data files with the exact same size. Then we have another trigger feature, which is to manual trigger, to force a manual trigger in the event-based mode. So if I have an event, let's say, let's create an event. So whenever I press the space bar, the recording should start. Okay, so whenever, usually, or how it has been until now, I can arm my trigger, or I will arm it now, and then the statistical recording has started. But the waveform recording does not start until the event actually happens. So if I press my spacebar, now I can see up here that the event has happened and the recording has started until I press stop. Maybe let's use a recorder to see that better. Just some signal. We just want to see the markers. So again, so if I arm the trigger and I press the space bar, we can see the marker that it has started now. If that event does not happen, then the waveform recording would not start. However, now it is possible that I force a manual trigger. So yeah, arm my trigger, and now I see if I stay on the button, I can see manual trigger. So I'm not pressing my space bar, but I can press manual trigger and the waveform recording starts anyway. So I don't have to wait for an event. I can just force a manual trigger if needed. This also works again via Skippy, so I can also show you that. Make it a little bit smaller. Okay, I hope you can see. Let's maybe delete those and put it more on this side. Okay. Okay, so I have those settings, and now I can start the recording. This would arm my trigger, so my trigger is armed. And if I resend my comment store start as it is here, again, we can now see the waveform recording has started, even though the event has not happened yet. So it works both in the GUI directly or via Skippy here.
A very nice and important feature if something happens and you need to trigger the system. You can do it now manually. Perfect. Perfect. So very nice. And finally, there have also been some changes made to the file name declaration and to the viewability and usability of formulas in the channels menu. Can you show us these two small changes?
Yes. Before I wanted to show you something else too, which also is in combination with the trigger. It's the pre-time. Forgot about that, maybe.
Oh yeah. Okay.
So in combination with the pre-time, there's also change in the freeze time. So if I come here into the system settings to the advanced setup, you can change the minimum duration of your freeze time. So just to remember, the freeze time would be the time whenever I click on the freeze button. I have a defined time here, which now would be like 20 seconds or more. It depends on your sample rate. So the higher the sample rate is, the shorter is the freeze time usually. The freeze time stores the waveform data for a period of time, even though we're only in the live mode, so not recording, but we're in a live mode. So usually, per default, it depends on the sample rate. But there are some applications or some customer need it to be longer than the default 1 to 20 seconds. So you can set the defreeze buffer up here up to 60 seconds actually. So you can set up to 60 seconds of minimum duration of the freeze buffer. However, this should be done carefully since it will lead to increased memory consumption. So depending on your PC, if you use it on the sample rate, it just depends on different things. You should use it carefully and maybe try it out what works best. If needed, if not needed, then you can just leave it on default. But if you set a higher time here, you can also set a higher time on the pre-time here. So now the pre-time can also be set up to 60 seconds before an event happens. So here you can see what the pre-time is, or rather how it works. If I arm the trigger and the event happens here, you can set a pre-time, which is a time which also stores the waveform data before the actual event happens, up to 60 seconds. So that is also possible now to do. Okay, coming back to your questions. These were the grouping of formulas, right? Did I forget
Yes,
something
exactly.
else now?
No, I'm
No.
just reading through the script. All good. We're all good
Okay,
now.
perfect.
It's the
Okay.
grouping of formulas and the file name pattern that
Oh
changed
yeah,
as
the
well.
file name pattern. Okay, so I can show you that before, since it's just a
Yeah.
small feature. We have introduced the file name pattern a couple of versions before, where you can individually set your file name. And we have the local counter here. So the local counter is like persistent. It goes even, it increases even if you close Oxygen and open it up again. And before there was a reset button to reset it to 0. Now we have changed that to a text field, to a number field, where you can set any number if you want. That is actually coming also from a customer, since the customer wanted to start from a specific number. So that is possible now. Just a small hint. So you can reset it to an individual number here. Okay, coming to the grouping of formulas. It is now possible to have a better overview in your channel list with the grouping of formulas. So as we can see, if you set a formula, if you add a formula, you get a new section here. So if we add one again, you can see we can add a formula group name. So let's say my formula group. And I can add my formula. And I can see there's a new section of formulas up here. Whenever I add a new formula, I can just enter the same name. And my second formula will be added to this group. It is also possible to edit the group name, or not to edit the group name, to add a new group name for this specific formula. For example, hello Ivica. And then a new section of formulas will be made. Therefore, it's also possible to regroup your formulas within the settings. So if I don't want to have this formula, or I want to group this formula to this group, I just enter the name. And as I can see, I have in the end now 2 formula groups with the according formulas channels in there. So that just makes a better overview of the whole channel list.
Definitely, the viewability is way better if you can group the formulas in different groups and also move them if necessary. Perfect,
Yeah.
Verena. Perfect. And at the very end, as always, when we talk about Oxygen and updates, is the view in the future. So can you give us some hint, or what can we expect in our next release?
Yes, of course. So actually, to make it a little bit easier, I am opening our website because there has been a change. If you go to Oxygen software, we can actually see now, we can actually see the Oxygen roadmap on the website. So I wanted to show you this.
Okay.
We can see the features which has been released for example, Oxygen 5.5 and 5.6. So this is the release right now. And we can see the features from the future release, which is the Q3, so end of September. So we get a new calculation module for frequency measurement for periodical signals. There are some CAN updates, OBD2 over CAN, for example, possibility to add with messages, and some user interface improvements. Some export features. We have a new export format, export selection of statistical values. So you can actually select if you just want to export the average, minimum, maximum, or RMS value from the statistical data. Some user experience updates. So in the event list menu, there you can display the date and the time. The mathematical statistic calculation starts actually from the start of the measurement whenever you press start measurement, start the recording. And you can split the export with the trigger event. So with a new trigger event, a new export file will be created. For the OXYGEN SDK, there's always, our developers always work on that too. And right now, they also concentrate on the documentation to make it even easier, like an easier entry for the Oxygen development. And they also work on more tutorials and examples which are available.
Very nice.
And there's also a lot of work with the cooperation for Müller BBM to configure Oxygen channels from the pack environment. So there's also a lot of work in there.
Perfect. Very, very nice. Very nice. So, Verena, thank you for showing us the newest features within Oxygen with our latest release 5.6. To all the viewers, thank you for listening. If you have any further questions, feel free to contact me and my colleagues. Our contact data is available on our homepage and on social media. So far, I don't see any questions, Verena, so we are good to go and good to end this webinar. Everybody, thank you for listening. We are going to put this webinar on YouTube as well after all the live sessions are done. Thank you for watching and see you next time. Bye-bye.
Thank you. Bye.